So in problem number 39, we have this piecewise function, and we want to find the critical points and use those critical points to help find the extreme local values. Let's go back and say, okay, what's the definition of our critical points? Our critical points are where the derivatives are equal to 0 or where our derivatives are non-existent. Well, if I want to look at y prime here, and I'm looking at the values of x that are lower than 1, can I read off what their slope is going to be? -2 when x is less than 1. I agree. Can I look when the values of x are greater than 1, what the slope is going to be? 1. And then I ask one more question. But you have to come up with the question. Is it? I hate the word it.
Is the derivative defined at 1?
Is the derivative defined at 1, Jordan?
No.
No. The derivative does not exist at 1. What does that mean for us? Then that must be where the critical point is. So the critical point is going to be when the function is equal to 1 comma. Does that work for both of them?
Yeah.
1 comma 2. So there's our critical point. Next question. Now that we know it's a critical point, we know that this point may be a local extrema. How can we use the derivative to help us find that out? Well, the derivative function, as we saw, it's undefined at 1, and prior to coming up to 1, it's negative, and after coming up, or after leaving 1, it's positive. And when I imagine this in my mind, I see it decreasing and increasing, or as Anthony just said.
Yeah, I was just wondering that.
Although, to be correct, ready? The difference being,
Do you remember when Brash made us get up? Mr. Brash, when we were going over
Oh my god.
basic functions of graphs, every couple of days he made us stand up and make all 12 basic
That was
graphs.
hilarious.
so really we have something that looks more like that.
No, I probably couldn't do it right now.
Because the slopes are constant on both sides, so it's not curvy. All right. So our conclusion is that at this critical point of 1, 2, what's going on? Okay. Okay. It has a local minimum of 2 at x equal 1. Again, I want to always tie the word minimum and maximum to y values. It has a local minimum of 2 at x equal 1. Did you have to do cubics?
Yeah.
Or that'd be more like this.
We
This
did
would be-
cubics,
yeah,
and
that'd be a
then
cube root.
E to the x, and he would like correct you on the slope of your arms,
No, e to the x. I'm sorry, that was e to the negative x.
and 1 over x and all that.
You know, I don't have enough arms to do.
Yeah.
Because you'd be like,
No,
Alright.
my favorite is when he told us to do integer of x.
oh my god.
So we're all like trying to make like lines.
Like Egyptians. All right. So anyway, that's that.